if you remember just one thing, this problem is going to be very easy for you, in which there are two convex lenses made up of glass whose refractive index is 3/2, and there is a liquid, that is water, in between, that is a concave lens whose refractive index is 4/3. Just remember only one thing: for a concave water lens, focal length is -3f/2. If you remember this point, the problem will become dead easy for you. And already it is given that focal length of these two lenses, that is f1 is equal to f3 is equal to f given. And for water lens, the gunshot formula is, it is 3f/2. That is enough for you to solve the problem. Then you know net focal length is going to be 1/fn is equal to 1/f plus second one is going to be negative lens, so we can write this as 3f/2 plus again 1/f. So therefore 1/f net is equal to 3f as an LCM, so 3 minus 2 plus 3, therefore 1/f net is equal to, here is going to be how much, 6 minus 2 is going to be 4/3f, therefore f net is equal to 3f/4. Your answer is this one. My dear students, see the problem which is asked in previous year questions. These type of questions are asked in many a times, even in Neet and JEE Mains. And you can see the problem solution given in the books. It's a very lengthy solution. He uses lens maker's formula and applies the data given here, supplies the data and replies the answer. But let me give you one simple shortcut method here. Whenever silvered lenses are there, in which a plane surface is silvered and this is a concave surface, in such situations, instead of doing all these lens maker's formula, applying infinity and all these things, I'll give you a simple shortcut. The simple shortcut is, you can find by using the focal length formula, that is r/2 into mu minus 1. This is going to be your shortcut formula. Simply apply this shortcut formula whenever you get plano-convex lens and plane surface is silvered. That's it. This is enough to solve the problem. You can just take f is equal to r, and what is r given in the book, in the problem? 10. So 10/2 into 3/2 minus 1, because he has given the refractive index as 1.5, which is nothing but 3/2. So what is going to happen here? 10/2 into 3/2 minus 1 is nothing but 1/2. So 2 gets cancelled. F is equal to 10. That's it. This is a simple shortcut formula. If you want that whenever plano-convex lenses will come, directly focal length will become radius of curvature. Directly focal length will become radius of curvature, means you need not even solve the problem. That's it. See, this is going to be your answer. Question is having, my dear students, how can you solve the problem of a plano-convex lens whose refractive index is given, okay, and it is given as 3/2 or 1.5, both are same, and radius of curvature is given as 15 centimeters. In such cases, how can you find out the focal length? It's very simple. The shortcut formula you have to apply. Need not apply all these lens makers formula. You can just apply f is equal to r/mu minus 1. You'll get an answer very super simple way. And radius, how much it is given? It is given as 15. And this is going to be mu minus 1, which is 3/2 minus 1, which is 15/1/2. Your answer is 30 centimeters. Some of the students are asking doubts. If it is a silvered lens, for example, this part is silvered, then what is the answer? I have discussed in the previous question also. See here. If it is a silvered lens, your formula is r/2 mu minus 1, where you are getting an answer as 10 centimeters. I have already discussed in the previous problem, but some of them has doubts. Silvered lens is different from unsilvered plano-convex lens. In a silvered lens, what is going to happen? If you silver this part, then it is behaving like a double lens. How? Because the mirror image of this lens will be like this. Because this is silver, it's acting like a mirror. Then it is acting like an equiconvex lens. This plano-convex lens, which is silvered at one side, is acting like an equiconvex lens now. Okay, so that's why you have to apply r/2 mu minus 1. Whereas in just here, in this problem, where it is unsilvered plano-convex lens, you are getting the formula as r/mu minus 1. Whereas here it is r/2 mu minus 1, as it is silvered. And if it is silvered, the mirror image will become a convex lens here. Double it will become, so you have to apply 2 here. Hope you have enjoyed. Thank you very much. Students, whenever he has asked refractive index of a convex lens, he has given What he has given? Radius of curvature he has given. And he's asking us to find out what is the refractive index. Power he has given. Power is also given as 10 diopters. 10 diopters. Then generally books will explain by using lens maker's formula and make the process very lengthy, but as you are a repeater, you have got a very less time in JEE Mains and Neet. You can solve by using a simple comedy formula which is easy to remember. It is refractive index is equal to rest in peace RP divided by 200 plus 1. This simple formula can help you to solve the problem in just a single step. Okay, so what is that? Mu is equal to R into P. R is nothing but 10. P is nothing but 10 divided by 200 plus 1. So 0 cancels 2 zeros. So half plus 1 which is equal to 3 by 2. Your answer is ready. Hope you have enjoyed.
Dear students, this is the question asked in previous year Neet. Here two equiconvex lenses are joined together. Their focal length is same. Surprisingly, in the second case, we are adding one more liquid in between these two lenses, and that liquid is taken as glycerin, and this liquid is also having same refractive index. That means refractive index of these two lenses are 1.5, that is equal to 3 by 2, and even the refractive index of the liquid is also 3 by 2 in between. That means this complete structure is behaving like one lens. This complete structure is behaving like one lens. Surprisingly, the shortcut formula is whenever same type of lenses are joined together, in the first case, focal length will become half. You have to remember this. Whenever equal convex lenses are clubbed together, joined together, their focal length will become half. And in this case, if you observe, what is happening, you know? These are the two lenses. In between there is one more lens which is having glycerin. See, the focal length of the first lens is taken as F, the focal length of the middle lens is taken as minus F, and the focal length of the last lens is taken as F again. These are convex lenses, their focal length is positive. This is a concave lens of same refractive index whose focal length is negative. That means this lens and this lens focal length gets cancelled. Then at last only one lens is left whose focal length is F. So in the second case you have to consider the focal length of the second combined lenses is taken as just F. That's it. No need to solve this problem here. You can just write F1 by F2 is equal to F by 2 by F. So getting cancelled, 1 by 2 is going to be your answer. That's it. You need not do all this process. The simple method is whenever the convex lenses are clubbed, focal length becomes half. Whenever glycerin is there in middle, whose focal length is same, whose refractive index is same, one is positive, one is negative, getting cancelled, only one lens is left. The answer is F. That's it. Divide them, find the ratio, you'll get the ratio as 1 by 2. That's it. Simple. So simple it is. My dear students, this is a case of an equilateral prism. This is a case of an equilateral prism in which refractive index of the prism material is given as √3. So you can just see the question solution given in the books. Whenever an equilateral prism comes, blindly don't think about the concept and that anything else. You just write this formula. Sin I is equal to mu into sin A by 2. Your answer is ready. In fraction of seconds without pen and paper you can solve the problem. How? You can just see here. Sin I is equal to √3 into sin A by 2, sin 30, which is nothing but √3 by 2. And you know that √3 by 2 is nothing but sin 60. So therefore, you have got the answer that angle of incidence is nothing but 60 degrees. You can bypass all these things. Thank you. My dear students, this is a case of two thin prisms, and in this situation it is said that the combination of prism produces dispersion without deviation. In such situations, this is the textbook solution given here. Need not follow these lengthy solutions. I have got a simple shortcut formula for you. That is, angle of a prism is inversely proportional to mu minus 1. A2 by A1 is equal to mu1 minus 1 by mu2 minus 1. You know that mu1 is given given as 1.5. 1.5 minus 1 by 1.75 minus 1. You will be getting how much here? You will be getting 0.5 by 0.75, which is nothing but A2 by A1. A1 is given as 15. Okay, so if you transfer this, you will get directly the answer is A2 is equal to 10 degrees Celsius. Need not do all these lengthy methods. A simple formula, if you remember, you can get the solution in fraction of seconds. My dear students, you can just see this problem. This is a previous year problem asking Neet. How can you solve this problem? You can just see this is a coin. A light ray enters outside the water and it is grazing to the surface. It is grazing to the surface. That means that if you draw a normal here, that means this is going to be a critical angle. If you are drawing a normal here, this is going to be a critical angle. If this is a critical angle, this is also critical angle, because when you draw these two parallels, alternate interior angles are going to be same. This is C means that is also C. You all know the formula for refractive index. Mu is equal to, if it is a case of critical angle, you write mu is equal to 1 by sine C, and you also know that refractive index formula is velocity of light in air to that of velocity of light in water. That's it. Your formula is ready. You will get the answer in a super simple way. Now you write 1 by sine C. This is going to be sine C. So sine C is nothing but opposite side by hypotenuse. This is 4, this is 3, this is 4 means this is 5 according to Pythagoras theorem. 3, 4, 5. Sine C is nothing but opposite side is 3 and this is 5. 5 means you can write this 5 in the numerator, and this is going to be 1 by C by V. What is C? You all know C is nothing but 3 into 10 power 8 divided by V. Okay, so he's asking us to find out V. It's very simple. You can find out V. Now take this 5 by 3 is equal to 3 into 10 power 8 by V. You can find out the value of V, and you'll be getting the value of V as 1.8 into 10 power 8. That's it. So simple it is. No need to worry. My dear students, this is a previous year question in which there is a thin prism, and this thin prism is silvered along the side AC. It has been silvered along the side AC, and a light ray enters from this side along AB and it falls on the side AC perpendicularly in such a way that it goes, and after striking it retraces back. It retraces back along the same path. What is the meaning of that? The meaning of that is it just strikes the side AC perpendicularly. I told that whenever a light ray, either it passes perpendicularly if there is no silvering, or if it is silvering it retraces back. In all such cases, I told you that geometry says that this angle of a prism and refractive index, this angle of refraction, they will be always same. That means this R and that A is going to be same. That's it. It's a simple solution here now. You have right now mu is equal to sine I, and this is sine R. Okay, so sine I is nothing but sine 2A, sine R is nothing but sine A. This implies that mu is equal to sine 2A is nothing but 2 sine A cos A divided by sine A. So getting cancelled. Well, what is your answer? He is asking us to find out the refractive index. The answer is 2 cos A. That's it.
My dear students, don't swipe. You may miss a wonderful physics short trick for Neet 2024. Just remember. See here. The problem says that light ray enters and it deviates. It is refraction. It is said that angle of incidence is double to that of angle of refraction. In such situations, he is asking us to find out what is mu. That's it. Sorry. What is I? He is asking us to find out what is I. How can you find out that one? Snell's law says that mu is equal to sine I. Here sine I means sine 2R by cos sine I by sine R. So this is sine R. That's it. Here this sine 2R means 2 sine R cos R divided by sine R. Sine R gets cancelled. What is left now? This is mu. So you know that cos R is equal to mu by 2. Cos R is equal to mu by 2. This implies that R is equal to cos inverse of mu by 2. But he is asking us to find out what is I. and you know I is nothing but it is double to that of refraction. Therefore 2 into r, this right, 2 cos inverse of mu by 2. So simple it is. Hope you have enjoyed this. My dear students, this is a previous year question of Neet. Okay, you have seen the mentioned year also. You can see there is a air bubble inside here. There is a air bubble here at this place. Okay, now from this side if you see, the bubble appears to be closer, and that too it is 3 centimeters. From that side if you see here, okay, it appears to be 5 centimeters. Okay, then what is the thickness of the cube? That is the question actually. You can just see the question solution given in the books. It requires 3-4 steps here to solve the problem, but I am going to tell you a shortcut method so that you can solve this problem in a single step here. Okay, so what is that single step method? Let us discuss about that, isn't it? So refractive index is given as 1.5. So I'll tell you that. Okay, this is taken as it is taken as real thickness by apparent thickness. Mu is equal to real thickness by apparent thickness. What is the real thickness? We have to find out. So real thickness is equal to mu into apparent thickness. And what is mu? It is 1.5, can be written as 3 by 2. Into apparent thickness means you can take 3 plus 5. You have to take this apparent height and that apparent height. That is 3 plus 2, I mean 5, that is 8. So this is taken as 2 4s are 8, 4 3s are 12 centimeters. Is it not a shortcut method? In which chapter you need a shortcuts? You can just comment below. If I find anybody's comment useful and worthful, then I am going to give you a free ebook for you for these shortcuts. I'll give 100 shortcuts ebook for you, free of cost. Okay, if you mention your WhatsApp number also. Thank you very much. My dear students, you can just see the problem here. This is a problem asked in ray optics. If the lens is in air, the focal length of the lens is given as 18 centimeters. It is 18 centimeters. But if the same lens, when it is immersed in water, what happens to its focal length? For this, the process is given. He has used lens maker's formula, and he has taken a lot of time to solve the problem. But especially if it is water, no need to do all these things. You just remember one thing. Focal length of water is 4 times the focal length in air. That's it. Directly I will show you how are you going to get this 72. It's very simple. In water, focal length in water is equal to 4 times of focal length in air, which is 18 centimeters already given here. So 18. Okay. It is going to give you 72 centimeters. Why do you do and waste a lot of time? In which chapter you want the shortcuts? You just tell me. I'll complete first ray optics and go for the problem asking Neet. And this is a lengthy solution given in the books. I have got a single step solution for you. There are 2 plano-convex lenses which are arranged like this. In between there is a liquid whose refractive index is 1.7 given here. For that he is using lens maker's formula, making the problem very complex. Sign conventions will come, you will do mistakes also. But there is a single step solution. Here focal length net is equal to r by 3 minus 2 mu is a simple shortcut formula. See this one. You can just write r. R means radius of curvature. That is 20 centimeters. 3 minus 2 mu. 2 into mu of a liquid is nothing but 1.7. So 20 divided by 3 minus 2 into 1.7 is 3.4. Okay. So what are you going to get now? You will be getting 20 by minus 0.4. So your answer is ready. You'll be getting 50 centimeters. So you will be getting the answer in just a single step formula. Hope you have enjoyed. This is highly problematic question for especially Neet students, but I have got a shortcut for this. You can just see the problem here, and you can just see the lengthy methods given in the books. And this is a diagram. Actually there are 2 lenses, equiconvex lenses. In between there is a liquid, and refractive index of a liquid is mu L. Okay. It is mu L. And it's asking us to find out the net focal length. The formula for net focal length is F net is equal to R by 4 minus 2 mu. This is a shortcut formula. Directly you will get a single step formula method. You need not write all these things. So F net is equal to R. What is the value of R here? If you observe, R is given as 20. 20 by 4 minus 2 into, what is the liquid? 4 by 3. Okay, so if you solve this one, this 3 comes to numerator, becomes 3 2 is 660 minus is going to be 8. 12 minus 8. So 60 by 12 minus 8 is going to be 4. Okay, so it's going to be how much? 15 centimeters. So directly we got the final solution. Hope you have enjoyed.
Dear students, see the lengthy method given in the books. Not necessary. Take the simple shortcut formula here. If this is a liquid, water present in between the two convex lenses, then you have to do the problem by using lens maker's formula. Then I have got a shortcut formula for you. Net focal length is nothing but 3f by 4. That's it. Then net focal length f is given as 20. So 3 into 20 by 4. Your answer is plus 15 centimeters. As you are getting plus here, that's why it is a converging lens whose focal length is 15 centimeters. Therefore, D is the correct option. Thank you very much.
Students, see the infinite series question. You will feel infinite tension to solve this problem because you have to apply the quadratic equation. See the lengthy methods in the books. How would it be if there is a single step formula for this? The single step formula is resistance across AB for this infinite series. When all the resistors are 1 ohm, then resistance across AB is equal to R into root 3 plus 1. This is a single step shortcut formula. You have to do only that. You have to apply R is nothing but 1 ohm. And this is going to be root 3 plus 1. That's it. Your answer is ready. Your answer is ready. If the resistors are 2 ohms, you need to do just 2 into root 3 plus 1. That question is also here. You can just see.
My dear students, see the lengthy methods given in the books. Not necessary. I have got a simple single shortcut formula for the problems of combination of lenses. You know these type of problems we have to use lens maker's formula, add the resultant focal length and get the final answer. It will take more than 1 minute. I am sure that it will take more than 1 minute. How it would be if there is a single shortcut formula? You are having a simple shortcut formula to solve this problem. Very easily, you can just see here. If you use this formula, you will get the final answer in fraction of seconds. Let me check it out. These are the two lenses which are having refractive index 1.5. That means these are made up of glass. And in between there is a liquid lens whose refractive index is 4 by 3. That means there is a water. In such situation, directly have a shortcut formula. You can apply this formula. Here, radius of curvature is 10 centimeters. You can just apply 3 into 10 by 4. Directly you will be getting minus 7.5 centimeters. Is it so easy? Thank you very much.
Let me solve the problem in a shortcut method. Okay, so you are having a lot of problem with this solution. I know about that. So I have created a shortcut for you. Let me discuss about that shortcut in a super simple way. What is that shortcut? Let me discuss about that. Okay. The simple technique is, what I meant to say here is, you all know this is a prism ABC. A light ray enter into the prism making certain angle of incidence I, angle of refraction R, and it passes through the other side AC perpendicularly. If such situation comes, geometry says that angle of refraction and angle of prism, these two will be same. Whenever this type of situation comes, that the other side, the light ray passes emergent ray, this is said to be emergent ray, it passes perpendicular to side AC, then the condition according to geometry is this angle of refraction and angle of prism, they will be same. If you remember this simple concept, your 90% problem is solved. The simple thing you have to do is apply Snell's law. What is this Snell's law? Mu is equal to sin I by sin R. But for small angles, thin prisms, sine are not present. Only sine is cancelled. Then what is left? Mu is equal to I by R. And you know I is equal to mu into R. But I said R is equal to A. I is equal to mu into A. That's it. You need not worry. It's a simple solution. Hope you have enjoyed. Thank you.